Welcome to a lesson on functions. How do we know what a function is? We need to define it in grade 12. It is simply a rule that assigns for every input value exactly one corresponding y value. So if you have one input value, you have to have a corresponding y value. That qualifies it as a function. So the following condition too. If you have a vertical line test, it's a line that's drawn down, it has to cut the graph or the figure once, then it will be noted as a function. In the case that it cuts it more than once, it will be considered not a function, but rather a relation. Yeah. So let's see if the vertical line test will cut this graph once, twice, more than that. So let's see. In this case, we'll use a dotted line to just check. Because if I draw a line, it will be a bit confusing. Because then it will be more than one line. Right, let's see. The test on the left and on the right, it cuts it once. And the other one also cuts it once. Therefore, people, it is a function. There we go. Let's move on to the next one. Right, so now here we get a figure. Now, what is this called? What type of graph is this? A quadratic function. The shape of the graph, we would say it's a parabola. Right, so this parabola can be concave up or concave down. Some people say smile. And then, so let's do the vertical line test here. Draw a dotted line down. It's always best to use more than one in order just to test if it really works. Right, let's see how many times it cuts. Once there, and then once again. So therefore, we can conclude that this is a function. There we go. Right, let's move to the next one. What is this one called? Now, some of you will definitely know what this one is called. Before we identify it, let's add in these dotted lines. Are these vertical line tests? What do you think? It is simply, let's see, can you post in the comments? It is hyperbole, and those lines we indicated now, it's called the asymptotes. There we go. It's an asymptote, and specifically to give the value of this asymptote, it's y equals to 1 because it cuts at 1 there. And then the other one is the x asymptote, it cuts at -1. Right. So let's move on. Is this a function or not? What do you think? Let's do the test. Now I use the dotted line in a different color so that you don't get confused of me drawing another asymptote. Right, so we're drawing it down. And we see there, it cuts it once again. Let's draw the other side. And there you'll also see that it cuts it once. The vertical line test cuts once, and then we can conclude because it cuts it once every time a vertical line is drawn, it's therefore a function. What graph is this? Let's add another dotted line here. Now you see I did the dotted line slightly below 1, because if I did it on 1, it would look like the graph is actually touching that line. And what do we call that line that the graph is always approaching but never touching? It's an asymptote, and this graph is an exponential function. Right, let's test it. Cuts it once, let's draw somewhere else. Cuts it once, and because it cuts it once on every time we'll draw a vertical line test, it is therefore a function. Let's do the last one. Right, so here it's a circle, but you also see later in the grade 12 where we will use this. Right, let's test it. Let's see how many times it cut. it cuts it twice in both occasions. Right. And whenever the line is drawn and it cuts it more than once, we can conclude that this is not a function, but a relation. Right. Here's a linear function. It's a line. When you're asked to sketch this following things that you need to consider, you must first find your intercepts. Right, your x-intercept and your y-intercept. Then you, in your mind, you must draw a picture of what this graph will look like. So you need to know the shape. And then you must check, does it have any asymptotes? Now, only two types of graphs in our case here has asymptotes. So let's do the intercepts first. Right, let's determine the x-intercepts first. Then to determine the x-intercept, you must set y equal to 0 or put y equal to 0. Either way, either notation will be acceptable. And then we're going to say 0 equals to 2x plus 2. And now we're going to solve for x. It'll be negative 2 equals to 2x divided by 2 both sides. X is therefore equal to negative 1. Now we have to write in coordinate form so that we don't get confused. It will be negative 1 and 0. That's my x-intercept. My y-intercept, I have to set x equal to 0. Right. So it's going to be y equals to 2, open bracket 0, plus 2. Therefore, y is equal to 2. And then we write it in coordinate form. And there we go. Right. Now that you have this, it becomes very easy to draw my function. But now I need to get the shape in my head, so I need to decide what this graph will look like. So just imagine this was a perfect circle, right? Right, the head rather. And so if the gradient is positive, it will be going upwards. If it's negative, it will become downwards. If it's vertical, it will be undefined. And if it's horizontal, it will be 0. Right, let's plot our points. So here you would see that this graph continues forever. And so that coordinate there and on the x-axis is going to be negative 1 and 0. And on the y-axis it would be 0 and 2. So there's our intercepts, and there we draw the function. Plot the 2 and you draw your line through it. Right. So we have to determine the domain. Now, a question that I always ask my students is, how far will this graph go in terms of the positive numbers on the right and the negative numbers on the left? How far will the graph go? Right. So we can use lines to indicate. So okay, it starts there by 2, it comes by 0, it goes on the negative side. Now because this graph has arrows on either side, it means that it continues forever. Right. Now my question to you is, if I say it continues forever, does it ever stop somewhere? Does it end? Does it stop on the left? Does it stop on the right? No, it doesn't, right? Okay. So we can then write the conclusion. It's the following. Because it never ends, we can say x is an element of, on the left hand side, you have obviously the biggest number that we know that never ends. It's negative infinity. And then on the right hand side, the biggest number that continues forever, that we don't know what the biggest number is, but we use a symbol for it. It is positive infinity. And we use circular brackets here because it does not include that number, the number that we don't know. Or we can put it in simple terms, because it takes all the numbers that exist. X is therefore an element of real numbers. So that could be your domain for a linear function. There we go. Let's go to the range. So we're going to do the same approach here, but simply just using the y-axis. Remember, the question is how far does the graph go? On the negative side at the bottom or the positive side on the top? Right? We have arrows because this graph continues forever. Okay, let's start the test. So go there with positive values, then it comes down. We check, goes on top for the positive values till infinity. The bottom we check, it continues for every value. Right, it will continue forever. That's why we have arrows on either side. Right, does it end? No, it doesn't. So therefore we can say y is an element of negative infinity, which is the negative numbers here at the bottom, and positive infinity, which will be the numbers on top, or the positive values. Or we can write it simpler. We could also say that, can you post your answer in the comments? It is y is an element of real numbers.